Consider an imaginary coin with exactly a 50-50 chance of landing heads or tails and a real coin that you toss 100 times. A chi-square test, it is appropriate when the data being analyzed are from a random sample and when the variable in question is a categorical variable. Find the critical chi-square value using a chi-square value table or a statistical software. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session of Unit 5, Session 6, we will have a discussion more on the chi-square and the goodness of fit. Now, what do we mean by goodness of fit? The chi-square provides a way to test how well a sample of data matches the known or the assumed characteristics of the larger population that the sample is intended to represent. This is known as the goodness of fit. Now, when we are collecting the samples for the various research, so whatever we are doing, so the samples whatever we are collecting, it should represent the whole population. So in order to check whether the sample is representative of the entire population, we have this test known as the goodness of fit. So the chi-square provides a way to test how well a sample data matches with the population. So if the sample do not fit the expected properties of the population that we are interested in, then we would not want to use the sample to draw conclusions about the larger population. Now, why is it necessary for us to check whether the sample is representative of the entire population? So, if the sample does not have the same properties as the entire population, then the sample will not be whatever the conclusions we are drawing from the research. So, it will not be representative of the entire population. So, it will give us misleading results. That is why it is necessary for the researcher to check whether the sample is representative of the entire population. So, we would not want to use the sample to draw conclusions about the larger population. So, we need to see that there is the goodness of fit. Then, for example, consider an imaginary coin with exactly a 50-50 chance of landing heads or tails and a real coin that you toss 100 times. If the coin is fair, then it will also have an equal probability of landing on either side, and the expected result of tossing the coin 100 times is that heads will come up 50 times and tails will come up 50 times. So, you have a chance. Suppose you have an imaginary coin. So, when you have an imaginary coin, you have a 50-50 chance of landing heads or tails. So, that is your imagination. So, when you toss a coin, there will be only two results. That is, either you get a head or you get a tail. But then a real coin that you toss 100 times. So, if the coin is fair, then it will also have an equal probability of landing on either side, and the expected result of tossing the coin 100 times is that heads will come up 50 times and the tails will come up 50 times. So, in the imagination we can say that we get head 50 times. When we toss the coin 100 times, we may get head 50 times, we may get tail 50 times. But then in real world, is it possible? If the coin is really fair, it will be possible. Then in this case, chi-square tells us how well the actual result of 100 coin flips compared to the theoretical model that a fair coin will give 50-50 result. The actual toss could come up 50-50 or 60-40 or 90-10. The farther away the actual results of the 100 tosses is from 50-50, the less good the fit of this set of tosses is to the theoretical expectation of 50-50, and more likely we may conclude that this coin is not actually a fair coin. Now, if you are having, in this case, the chi-square, if you are having the chi-square test on this flipping of a coin, then the actual result of 100 coins. So, when you flip the coin 100 times or when you toss the coin 100 times, you expect to have a 50-50 result. So 50 heads and 50 tails. But then when we actually toss the coin, we may get a 50-50, that is 100 50s, 100 tails, or we may get 60 heads and 40 tails, or it may be 90 heads and 10 tails, etc. So whatever, so this is the expected result, but actual result will be the something else. So it may be 60-40 or 90-10, etc. So we have to compare what is this actual. So if it is 90 for 90 and 10, but then observed is 50-50, the less good the fit of this test set of tosses is to the theoretical expectation of 50-50. Now what is the theoretical expectation? Theoretical expectation is when we toss a coin 100 times, we will get 50 heads and 50 tails. But then actual will be quite different. We may get 90 heads and 10 tails. So whenever there is a difference between the theoretical and the actual, then with the more likely we conclude that this coin is not actually a fair coin. So if there is a lot of difference between the theoretical and the actual, we say that the coin is not a fair one. So there is some discrepancy in the coin. Then a chi-square test is used to help determine if the observed results are in line with the expected results and to rule out that observations are due to chance. Now, in this chi-square test, we will be able to know whether determine if the observed results are in line with the expected result. So, observed result and the expected result are same. And to rule out the observations are due to chance. The chi-square test is appropriate for this when the data being analyzed are from a random sample and when the variable in question is a categorical variable. A categorical variable is one that consists of selections such as type of car, race, education attainment, male or female, or how much somebody likes a political candidate from very much to your very little. So, a chi-square test, it is appropriate when the data being analyzed are from a random sample and when the variable in question is a categorical variable. So, we have this chi-square test is used when when the data is analyzed from a random sample and the variable is a categorical variable. Now, what do we mean by a categorical variable? It is one that consists of such selections such as the type of car, race, education attainment, male or female, etc. Next, when to use a chi-square test. So, these types of tests are often collected via survey responses or questionnaires. Therefore, chi-square analysis is often useful in analyzing this type of data. So, the chi-square tests are useful when we have this survey type or questionnaire type of collection of data. Then, how to perform a chi-square test? So, there are the basic steps whether you are performing the goodness of it or a test of independence. So, create a table of observed and expected frequency. So, we have the observed frequency and the expected frequency. Use the formula to calculate the chi-square value. Find the critical chi-square value using a chi-square value table or a statistical software. Then determine whether the chi-square value or the critical value is larger of the two. Then accept or reject the null hypothesis. So, in this way, we will be able to have a chi-square test. So, that is, so you have a table of observed frequencies and the expected frequencies. Then use the formula to attach the chi-square value. So, what is the chi-square value? You have it with the help of the formula. Then find the critical chi-square value using a statistical table or a software. Then determine whether the chi-square value of is critical is larger of the two. Then we have the acceptance or rejection of the null hypothesis. Now, what are the limitations of the chi-square test. The chi-square test is sensitive to sample size. Relationships may appear to be significant when they aren't, simply because a very large sample is used. So, the chi-square test is sensitive to sample size. So, what are the limitations of this chi-square test? So, first thing is it is sensitive to the sample size. So, we may say that there is a correlation between the two variables. So, depending on the when we have a very large sample which is being used. In addition, the chi-square test cannot establish whether one variable has a causal relationship with another. It can only establish whether the two variables are related. Now, when you are using the chi-square test, we can say that it cannot establish whether one variable has a causal relationship with another. It can only establish whether the two variables are related. So, it will just say that the variables are related, but what kind of a relation they have, that we cannot know with the help of the chi-square test. Next, what is a chi-square test used for? A chi-square is a statistical test used to examine the differences between categorical variables from a random sample in order to judge goodness of fit between expected and observed results. So, it is a test used to examine the differences between categorical variances from a random sample in order to judge the goodness of fit between the observed frequencies and the expected results. Next, who uses a chi-square analysis? Since chi-square applies to categorical variables, it is most used by researchers who are studying survey response data. This type of a research can range from demography to consumer and marketing research to political science and economics. Then, is chi-square analysis used when the independent variable is nominal or ordinal? So, when do we use the chi-square test? So, nominal variable is a categorical variable that differs by quality but whose numerical order could be irrelevant. For instance, asking somebody their favorite color would produce a nominal variable. Asking somebody's age, on the other hand, would produce an ordinal set of data. Chi-square can be best applied to nominal data. Now, we should understand what is this nominal variable or ordinal variable. Now, for example, there is an example here. So, in the case of a nominal variable, suppose I ask someone their favorite color. So, if they say it is blue, then I assign 1 for the blue color, green for 2 for the green color, red 3 for the red color, 4 for the yellow color, etc. So, this we call it as the nominal variable. So, if that person opts for blue, I give him 1. If he opts for green, I give him 2. If he opts for red, I give him 3. If he opts for yellow, I give him 4. These numbers, they are not representative of any value. They just signify the choice of the color. So, this kind of a numbering, we call it as the nominal variable. But suppose I am asking the age of the respondent. So, he says his age. So, that age, whatever he has told, that will be actually recorded, and that set of a record, we call it as the ordinal set of data. Next, the bottom line, there are two types of chi-square test, the test of independence and the test of goodness of fit. Both are used to determine the validity of the hypothesis or an assumption. The result is a piece of evidence that can be used to make a decision. For example, in a test of independence, a company may want to evaluate whether its new product, an herbal supplement that promises to give people an energy boost, is reaching the people who are most likely to be interested. So, in this test of independence, We have this example here. So a company may want to evaluate whether it's new product which is giving lot of energy, whether that product is reaching the most of the people who are interested in. It is being advertised on websites related to sports and fitness on the assumption that active and health conscious people are most likely to buy it. Now, all those people who are really very health conscious, they may be interested in buying such a product which will boost their energy. So, the most of the companies, they try to advertise their products through these websites which are related to fitness and sports. It does an extensive post that is intended to evaluate the interest in the product by demographic group. Now, the company has done an intensive poll, and just to see whether the people who are there, who are visiting the website, they are interested in that product. The poll suggests no correlation between interest in this product and the most health conscious group. So, when the poll results were taken, it was found that the health conscious people, those are more devoted to sports, they were not interested in the product, whereas those people who are not into sports or fitness programs, they were more interested in buying the product. So, we can see that in a goodness of fit, a marketing professional is considering launching a new product that the company believes will be irresistible to women over 45. The company has conducted product testing panels of 500 potential buyers of the product. The marketing professional has information about the age and gender of the test panels. This allows the construction of a chi-square test showing the distribution by age and gender of the people who said they would buy the product. The result will show whether or not the likeliest buyer is a woman over 45. So, there is a new product which has been launched exclusively for women over the age of 45 years. Now, they have conducted a testing panel. So, with the help of this panel, they will be able to know how many women aged above 45 are interested in buying the product. If the test shows that men over 45 or women between 18 and 44 are just as likely to buy the product, the marketing professional will revise the advertising, promotion and placement of the product to appeal to this wider group of customers. Now, when the results are out, or when the survey results are out, the marketing professional finds that this product is equally attractive to men, and this product is equally attractive to women above 18 and below 44 years also. So, what happens is, he will change his marketing strategy or the advertising strategy. So, he will see that whatever advertisement and promotion he has planned, there will be slight changes so that he will be able to attract all other people also into this wider group as the customers. The term goodness of fit refers to a statistical test that determines how well sample data fits a distribution from a population with a normal distribution. Put simply, it hypothesizes whether a sample is skewed or represents the data you would expect to find in actual population. So, the term goodness of fit is a statistical test that determines how well the sample data fits the distribution from a population with a normal distribution. So, it establishes the discrepancies between the observed values and the expected model in a normal distribution case. So, with the help of the goodness of fit, we will be able to establish the differences between the observed frequencies and the expected frequencies. So, there are multiple methods to determine the goodness of fit, including the chi-square. So, this the goodness of fit can be known with the help of the chi-square test. So, a goodness of fit is a statistical test that tries to determine whether the set of observed values match the expected under the applicable model. Second one is, they can show you whether a sample data fit an expected set of data from a population with normal distribution. So, if the population is from a normal distribution, we will be able to know whether the sample data fits the normal distribution. There are multiple types of goodness of fit test, but the most common is the chi-square test. The chi-square test determines if the relationship exists between the categorical data. Lastly, Kolmogorov-Smirnov test determines whether a sample comes from a specific distribution of a population. With this, we come to the end of this session. Hope you have all followed it. Thank you.